Hello everyone. Today is June 10th. It's the second lesson of the 12th week. Our topic for today is decomposition reactions. Our objectives for today are: describe decomposition reactions as endothermic reactions in which a compound breaks down into simpler substances. Describe the decomposition reaction of water. Describe how to test for hydrogen gas and oxygen gas. Please make sure you have the following resources ready with you: science notebook and your stationery. Before we start, please open a new page in your science notebook and write the date on the top right of the page. Write the title of the lesson on the next line in the middle. Let's review the 4 rules of chemical reactions. Chemical reactions are processes in which chemical changes take place. Reactants interact, they exchange atoms and form new products with different chemical properties. As an example, hydrogen gas will react with oxygen gas to form water. Water has new properties different than the properties of the individual elements. In a reaction, the number of atoms stays the same, no matter how they are arranged, so their total mass stays the same. This is known as the law of conservation of mass. Chemical reactions usually release heat. These reactions are known as exothermic reactions, where temperature increases, or absorb heat. These reactions are called endothermic, where temperature decreases. Right now, think of these questions. Pause the video, write your answers on your copybooks, and when you're ready, start the video again. Exo means exit, and thermic means heat. If heat is released, the reaction is called exothermic. This causes an increase in temperature, as an example, burning fuel. Endo means go in. If heat is absorbed, the reaction is called endothermic. This causes a decrease in temperature. As an example, photosynthesis. Photosynthesis is an endothermic reaction. Look how the plant absorbs energy in order to combine carbon dioxide and water, so glucose and oxygen are produced. Again, take a minute to think of these questions. Pause the video, write the answers on your copybooks, and when you're ready, start the video again. Did you write the answers on your copybooks? Let's check them together. Combustion is the scientific name for burning. It is an exothermic reaction because heat is released. Combustion reactions require fuel and oxygen gas to occur. Complete combustion occurs when there is a lot of oxygen. The products are carbon dioxide and water. Incomplete combustion occurs when there is insufficient oxygen gas. The products are carbon monoxide and water. Are you able to differentiate between endothermic and exothermic reaction? Classify each of the following chemical and physical changes as endothermic or exothermic. Write the answers on your copybook, then we'll check them together. During cellular respiration, energy is released. This energy is used to make activities. Accordingly, cellular respiration is exothermic. Look at the ice, how it's absorbing heat in order to melt. In this picture, snow is absorbing the sunlight energy and then will melt into liquid water. Just because ice absorbs energy to melt, melting ice is endothermic. In this picture, water particles are absorbing the sunlight energy in order to evaporate. Accordingly, evaporating liquid water is endothermic because energy is absorbed. What about making ice? Already we know that liquid at room temperature is almost equal to 20 degrees Celsius. The temperature of the freezer is below zero. Accordingly, liquid water is warmer than the temperature of the freezer. And then thermal energy will pass from the warmer object, which is the liquid water, to the colder object, which is the freezer. Accordingly, heat is released from the liquid water to the freezer. As heat is released, making ice is exothermic. The presence of this flame will tell that there's energy which is released. As energy is released, burning sugar is exothermic. In order to prepare bread, we have to put the dough in the oven. Accordingly, the dough will absorb energy and then the bread is made. Accordingly, baking bread is endothermic because energy is absorbed. If I put my hand next to the candle flame, I feel that energy is released. Accordingly, candle flame is an exothermic reaction. Right now, take a minute to check your answers. A decomposition reaction occurs when one reactant breaks down into two or more products. As an example, sodium chloride decomposes to give sodium and chlorine. Sodium chloride is the reactant. It is decomposed into product A, sodium, and product B, chlorine. It can be represented by the general equation AB gives the product A plus B. AB is the reactant which is divided or which is decomposed into product A and product B. Are decomposition reactions endothermic or exothermic? Do they need to absorb energy and then they are endothermic, or they release energy and then they are exothermic? Decomposition reactions are like we are breaking something into smaller pieces, and then for sure we need energy. For this to happen, electricity, heat, light, or another form of energy is needed. As decomposition needs to absorb energy, decomposition reactions are thus endothermic. Hydrogen peroxide is a widely used disinfectant for minor cuts and scrapes. You may have a bottle of hydrogen peroxide like the one pictured here in your medicine cabinet at home. Did you ever notice that hydrogen peroxide is always kept in a dark brown bottle like this one? Do you know why? The reason is that hydrogen peroxide has to be protected from light, or else it will break down into water and oxygen. This is an example of decomposition reaction. Are you able to write the chemical equation of this reaction? As we said, hydrogen peroxide is decomposed into water and oxygen. Hydrogen peroxide is the reactant which is decomposed under the effect of light into product A, water, and product B, oxygen. So I've started from one reactant which is hydrogen peroxide, and then I got two products. The first one is water and the second one is oxygen. Another example of decomposition reaction is copper carbonate, which is broken down into copper oxide and carbon dioxide. Copper carbonate breaks down when heated into carbon dioxide, it's the carbon dioxide, and copper oxide. I've started from one reactant, which is the copper carbonate. Under the effect of heat, copper carbonate is decomposed into two products. Product A, carbon dioxide, and product B, copper oxide. As I've started from one reactant and this reactant is decomposed into two products, this reaction is a decomposition reaction. Let's practice. Write a word equation for the following reactions and justify why they are decomposition reaction. First, carbonic acid found in soft drinks breaks down upon heating into carbon dioxide gas and water. Second, magnesium oxide breaks down when heated to produce magnesium and oxygen gas. Write the equations on your copybook, then we'll check them together. Are you ready to check the chemical equations together? As it's written in the given, carbonic acid is broken down into carbon dioxide and water. So, carbonic acid gives carbon dioxide and water. As I have one reactant which is broken down into two or more products, this reaction is decomposition. Similarly, magnesium oxide breaks into magnesium and oxygen gas. So, magnesium oxide gives magnesium and oxygen gas. As I have one reactant which is broken down to give two different products, this reaction is decomposition. Decomposition of water. Water H2O decomposes to hydrogen H2 and oxygen O2 when electricity passes through it. This reaction is represented by the equation water gives hydrogen gas plus oxygen gas. This type of decomposition reaction that occurs by means of electricity is called electrolysis. This chemical equation will tell me that water is broken down into hydrogen and oxygen. Look at the amount of hydrogen is double than the amount of oxygen. In this video, we're going to see how water is going to be broken down under the effect of electricity.
And so now you set them on the leads and the electricity can flow between the two push pins now, and so electricity is flowing through the water, and so that's enough energy to break apart the water, make it undergo a chemical reaction so that the H2O gets broken apart into H2 and O2. It's going to be hydrogen gas and oxygen gas, and both gases are going to flow up through the test tubes, and one of the gases is going to be in one test tube and the other one's going to be the other one. How do you know which one's which? Well, if you take a look at the amount of gas in each test tube, there's going to be twice as much hydrogen gas as oxygen gas. So you can see in the right test tube, you have twice as much hydrogen gas as oxygen gas. This is how experimenters first learned that the ratio of hydrogen atoms to oxygen atoms in water is 2 to 1. It's 2 to 1 ratio, thus H2O.
It looks like this space is empty, but in fact is filled with the gas. This tube contains hydrogen because its volume is double than this gas. Just because two particles of hydrogen have to react with one particle of oxygen to form two particles of water, when water is decomposed, the volume of hydrogen gas must be the double of the volume of oxygen gas. How to test for hydrogen gas? Get a lighted splint in contact of hydrogen gas. Hydrogen gas will explode and giving a squeaky pop sound. How to test for oxygen gas? Get a glowing splint in contact of the oxygen gas. Oxygen gas will make the splint relight.
Gas. Let's start off with a test for oxygen gas. As you can see here, I've got a gas jar and I've got a burning splint. Well, the test is if that I put a glowing splint into oxygen gas, it should reignite it. So let's have a look at that again. So I've got a glowing splint, the flame's out, and when I put it into the oxygen, it should reignite. So, to summarise, the test for oxygen is light a splint, then blow it out, and then stick it into the oxygen. If the glowing splint then reignites, that is the positive test to say that oxygen gas is present. So the test for hydrogen gas is when you light the actual gas, it should make a popping sound, more of a squeaky pop sound. Let's listen. There we go. Okay, so the test for hydrogen, as we just said as a summary, we light a splint, we place the burning splint into the hydrogen gas, and the positive test would be that the hydrogen burns with a distinctive squeaky pop.
Right now, let's compare combustion reactions and decomposition reactions. Combustion reactions are exothermic, so they release heat, while decomposition reactions are endothermic. They absorb energy. They need energy such as light energy, heat energy, electrical energy. As for combustion reactions, we need two reactants, the fuel and the oxygen gas. But in a decomposition reaction, just I have one reactant. In combustion, I'll get two products, carbon dioxide and water for complete combustion, carbon monoxide and water for incomplete combustion. But in a decomposition reaction, this one reactant is divided into two or more products. Concerning the combustion reaction, it needs a flame to start, but in decomposition reaction, it needs continuous heat, electricity, or light. when the source of energy will be absent, the reaction of decomposition will stop. As an example of combustion reaction, we have burning petrol. As an example of decomposition reaction, we have decomposition of water. Watch the tutorial again and take notes in your science copybook. Respond to the questions of the worksheet posted on Edmodo. As an optional project, design a poster to explain a decomposition reaction. Write how is it beneficial and write its word equation. Hope that you understood everything. If you have a question, send your teacher a private message on Edmodo. And thank you for watching.